All right, so percent mixture problems. What we're going to do is we have to remember what percents are. Remember we want percents are as decimals, and percents is to move to a decimal. It's 2 spaces. And decimals are smaller. And then we usually have the result equals percent times amount. All right, so when we're doing these problems, we are going to be looking at all that. I think I'm going to use a thicker pencil. So whenever we have word problems, you always want to read the question first. So in the lab, Christine has 2 solutions that contain alcohol and is mixing them with each other. She uses 200 milliliters less of A than B. So B is generally what we're going to be talking about. I'm going to call that X, and then A would be X minus 200. We're going to organize that a little bit better, but as I'm writing it, I'm going to make some notes. Solution A is 18%, so that is 0.18. Alcohol in solution B is 15%, so 0.15. How many milliliters of solution B does she use if the resulting mixture has 129 milliliters of pure alcohol? So total equals solution A plus solution B. All right, so we know that we need 129 milliliters of pure alcohol. So that's going to be 100% alcohol. That is 1, so we don't really have to worry about that. So this is 129 milliliters. We're going to be a little sloppy and not put the units in there. And that's solution A, which is 0.18. And then how much of A was that's where we have our notes of solution B minus 200. So it's 200 milliliters less A than B. So this is going to be X minus 200 plus solution B was 15%, so 0.15. And B, we decided it was the end of the comparison, so the then, so that is just going to be my X. And that is the problem that we're going to be solving. So we're going to use our order of operations, our math that we know, get rid of the parentheses. So this is going to be 0.18x minus, when I'm multiplying decimals times things that end in zeros, each decimal can cancel out one of the zeros. So this is really just 18 times 2, which is 36, plus 0.15x, and that is going to equal the 129. I'm going to add the 36 to both sides, and that will give me a grand total of 265. Add the 18 and the 15, so that is going to be 0.33x. Getting x by itself, we're going to divide both sides by that 0.33. And now, because I have a fraction or a division and a decimal, I really don't want both, so I'm going to move my decimal 2 spots to get rid of the decimal, and whatever I do the bottom, I have to do the top. So this is the same thing as 26,500 divided by 33 equals x. I'm going to have to divide that out. I don't want to get a calculator, so we're going to go 26500 divided by 33. I know it will go about 8 times. 24. Assuming I subtracted and added right. 2426. Nope, I probably have a number wrong when I'm thinking about this. We're gonna look at it. So we're gonna. All right, so when we're adding, the 129 plus 36 should be 165, not 265. So we are going to fix that. So 165, which is going to make everything work out a lot better. Looking at my problems, they usually work out a lot better than this. So we're going to change that and change in my problem. Someday I will do my work without any creative math. However, that is not today. All right, so this is actually going to be 5, which seems a lot better because 5 times 30 is 150, 5 times 3 is 15. Add those together, I get 165. And then I do need to go all the way over there, so we're going to add the zeros on the top. So this gives me x equals 500, which makes sense. It's going to have to be a lot more than the 129 milliliters to make it the pure alcohol. So that is my answer when we are looking at it. So looking at another one when we're talking about it, so we're still talking percents. So problem number 2, just so that we have another example, 2 factory plants are making TV panels. Yesterday, plant A produced 16,000 panels. 5% of these panels from plant A and 2% of the panels from plant B were defective. So 0.05, 0.02. How many panels did plant B produce if the overall percentage of defective panels from the 2 plants was 4%? So defective total equals, so that's going to be 4%, 0.04. 0.04, and that is going to be plant A plus plant B. So we're going to talk about that. So defective A plus defective B. All right, so I'm going to fill this in a second, but defective A is going to be 5%. So 0.05, and the number that they produced was 16,000. And then defective B was 2%, so 0.2. And that, we didn't know how many they made, so we're just going to call that X. So the total number of panels that we're making are the 16,000 plus X. So this is going to be 16,000 plus X, and this is going to be the equation that we're going to be solving. So we're going to distribute the 0.04 times 16,000 is going to be the same thing as 4 times 160. 4 times 100 is going to be 400. 4 times 60 is going to be 240. So this is going to be 640 plus 0.04x equals, distributing the 0.05 to the 16,000 is going to be the same thing as 5 times 160. 5 times 100 is 500. 5 times 60 is 30 with the 0, so 300. So this is going to be 800 plus 0.02x. Get the x's on one side and the plain old numbers on the other. I'm going to move that 0.02 to both sides, minus 0.02x, which means my x is going to be on the left, which means I get rid of the plain old number. So minus 640 over here. Whatever I do on one side, I have to do on the other. And this will give me 0.02x equals 160. Dividing by 0.02. I'll do this color. 0.02. 0.02. Yet again, I don't want to have the decimal in the fraction, so I'm going to move my decimal here. 1, 2. So this is x equals 16000 divided by 2, which is just 8,000. So 8,000 panels, and X was what my B was. So I have 8,000 panels in plant B made.